Okay. Okay. Hello, everyone. Welcome to building augmented reality experiences on Android with Azure Spatial Anchors. I'm so excited to be, giving this talk today. And let's just dive right in. So before we, dive right in, like really, um, I want us to explore the history of computing. So this started in like the 1970s when we think about, mainframe computers, and then moving into like, the early 1990s, late 1990s, we started seeing personal computers, which started with like those very big desktops that we didn't really like at the time. And then they evolved and they became smaller, flatter, nicer looking. And then we got laptops. And then this era still exists because a lot of us still have our personal computers, and that's how many of us even write the code that we write today that runs on the many devices that we build for today. And in the early 2000s, we started thinking about smartphones, and computing evolved into smartphones. You could have It was a BlackBerry at the time, and then from the BlackBerry came the Androids, and came iOS, and came other smartphones that existed in that time and still exist. And then now it's like when you look at PCs and when you look at smartphones, it's like this era hasn't gone away. It's just that things have come to join us. Things have, blessed us. Like we've been blessed with new things because of technology. And this is beginning to be the era of spatial computing as well. Personally, I believe that this decade is going to really kick off spatial computing in so many ways. And spatial computing, allows us to, interact with digital elements, in the real world, and be able to, and that's a different way that, nowadays people are interacting with computers. And what I'm going to be talking about today, which is Azure Spatial Anchors, really fall into the bracket of spatial computing, right? Because like said, I'm going to be talking about AR, and this that is one of the things that you can do with spatial computing. And now, looking at the fundamental challenges that exist in spatial computing in that space, in that mixed reality space, the two fundamental challenges that really exist is the ability to have a digital element in a particular area in your physical world, and once you leave that area and you come back, that digital element is in the same place as you left it. And this is called persistence. And also the ability to share digital elements with other people. And they can look at the same things as you're looking at. If it's some kind of game where you are supposed to be building a house, they can collaborate with you and build that game. The ability to do that is called sharing. And this is something that we have as human beings on a platter of gold, when we look at our physical space. One example is I'm pushing a I'm trying to I get a delivery, right? And I get it from like my doorstep, and it's really big, and I'm trying to push it to my room. If I leave it somewhere on the stairs, I know that it's there, right? If I leave it somewhere on the stairs and I go and I come back to that position where it was and it's not there anymore, it's like a red flag, because I'm like, okay, who took my package, right? If by chance I'm able to get the package to my room and I'm unboxing, I can call my friends. Oh, this is this package here. This is this box. All the items inside this box are a lot. Please help me unpack. The persistence part of this story was where I said I could leave this box at the stairs, and if I don't know, go to my kitchen or go somewhere else to grab a cup of water and I come back, that box, that package should still be in the same place, except somebody moved it. I should expect that it should be in the same place. And then the sharing part is, imagine if that package is my element. I want to be able to, tell my friends to help me remove something, to help me unpack what is in there and all of that. That is the sharing bit of it. And this is something that, like I said, is given to us on a platter of gold. But This is something that is a fundamental challenge when you look at spatial computing and mixed reality in general. And Azure Spatial Anchors exist to solve that problem. I'm going to be playing a video. Now I have a first video to play regarding that.
Minecraft Earth is an all-new augmented reality game for mobile devices that brings the Minecraft world into our universe, and it's launching soon in beta. Let's take a look at the beta experience. It all starts with you. Here's your character on the map. You can change your skin just like in regular Minecraft. You can see the outline of real-world houses and streets around you, but set in a Minecraft environment. Walk around the neighborhood and tap the icons to gather blocks and even mobs. The items are called tappables and can be found all around you. There are new mobs in Minecraft Earth to find and collect. Is this pig really a pig? Almost. It's a different mob variation. The muddy pig. Some mobs are rarer than others. Who knows what you'll come across? And of course, the chests are always shrouded in mystery. Anything you collect goes straight into your inventory. Every tappable gives you valuable experience points. After you tap enough tappables, you'll level up. As a bonus, you may also develop impressive cat-like tap reflexes. Once you've gathered enough resources, it's time to build. Any flat surface is an opportunity to create. Use a build plate, a small section of the Minecraft world, for you to build and play on. You can unlock more exciting plates as you level up. You can place blocks and mobs you've collected, or mine new blocks from the build plate. This is a living, breathing Minecraft world. Water flows the way you'd expect. Crops grow. Oh, and fire spreads. Fast. You play with friends you invite. Friends in your world can give you things by dropping them on your build plates, or they can take things away. In other words, only invite your nicest friends. Once you're happy with your creation, place it in the real world at life size. But don't just admire it from a distance. Go inside it. This is just the beginning. We can't wait to share more features soon. Sign up for your chance to play in the closed beta at minecraft.net/earth.
This is an example of sharing. As you can see, these two friends are building something in their Minecraft world, right? And they're able to do that because they can both see the same digital content and they're building on that. This is an example of persistence because when they're done building their, Minecraft element and they want to put it in the real world and make it a life size, they would expect that tomorrow, if they come back to the same place, they want to see this thing there and they want to be able to go inside as they did yesterday. And this is a challenge in spatial computing that Azure Spatial Anchors help us solve. But before I get deeply into the details of spatial anchors, I'll quickly want to introduce myself. My name is Adora, and I am a software engineer at Microsoft Mixed Reality. I am a tech content creator at Adora Hack. I have a blog and I have a YouTube channel where I talk about, software engineering, career growth, and my life as a developer. And you can find me on Twitter at Adora Nwodo as well. I am also many other things. I run a few communities and all of that. So now let's get right into it. What is a spatial anchor? A spatial anchor is a location in the real world. It's basically a reference frame to an actual real world location. So the anchor is not the object itself. The anchor is a reference to a location. And then, you can have that anchor and then you can now decide, okay, at this particular anchor, at this particular location, I want to render 3D content there. And a cloud spatial anchor, in this case, since we're talking about Azure Spatial Anchors, is, an anchor that exists in the real world that is shared with Azure. So if we are both using the same app, that has Azure Spatial Anchors, and I allow you see the anchors that I create. Once I once we are both logged into the app, if we scan like in the same room and we find all the anchors that currently exist in that location based on the app that I am using, I should also be able to see the content that is rendered there. And I'm going to play another spatial anchors demo that exists. So this demo is with a mobile phone and with a Microsoft HoloLens device. So there's a spatial anchor at this point, right? Where this location thing is. There's a spatial anchor right there. And if you look at the real world, you see nothing in that location. But when you look through that same space with a mobile device, and when you look through that same space with a HoloLens, this is what you would see. There are so many use cases for Azure Spatial Anchors, which from now on I'll be calling ASA. There are so many use cases for ASA today. If you look at gaming, I showed you, the Minecraft example initially. If you look at retail as well, there's so many ways that you could use ASA in maybe retail stores and maybe in helping finding goods and all of that. If you look at manufacturing, healthcare, there are other different AR use cases that exist in this space. And ASA is something that if we add ASA in our AR solutions, it could be a lot more amazing. And I'm going to play a wayfinding example that stuck to me so much because apart from the fact that it's a sample, it's a way to use ASA to do wayfinding, it's also, in line with the whole AI for good, which is helping people using AI to help people um achieve stuff and be more productive and do things that they might not be able to do by themselves. So let's just go ahead and watch this.
Navigate to my next meeting.
Your next meeting is with Juliet in Studio C. Would you like me to guide you?
Yes.
Are you starting from the lobby of Studio C?
Yes.
Pan your phone to map the room. Follow the audio breadcrumbs to conference room 1200.
Where can I sit?
Pan your phone to map the room. Table at 12 o'clock, empty seat located at 11 o'clock.
That's like the best thing I had. The day I was putting together this presentation, that was like the best thing I had seen that whole week because this went straight into my heart. I'm going to be very honest with you. So now I'm going to talk about how spatial anchors actually work. So if you look at this lobby, this is one of the Microsoft lobbies. And if you look at this, this is basically what you would see when you scan the room. When you scan this room, you would get multiple frames. This is the anchor. This is the anchor. This is the location that you said, hey, I want to save, I want to get a reference to this location in the real world, and this is what the anchor is. And these are, the frames that these are the frames that you record as a result of trying to scan the room and then figure out where your anchor is. So now let's go straight into using ASA with Android. The way Azure Spatial Anchors are set up today, you can build for Android, you can build for iOS, you can build for your different um, headsets that exist today. So, but for the purpose of this talk, we're only going to be doing things for Android because I am a Droidcon. So let's look at building a basic app that maybe you can use to create an anchor. You can find an anchor and then you can play with friends. So there's there's three things that are important here. The first thing is the Android app that you're going to be working with. The second thing is the Azure Spatial Anchors SDK that you're going to be using. And the third thing is a custom backend that you are going to use. And in this first step, the first thing that in this step of creating this, the first thing that you would want to do is save your anchor. So from your Android device, when you scan the room and you decide that you want to place a certain anchor in a certain location, what's going to happen is you're going to get a reference to that anchor and you are going to save that anchor on ASA. And ASA is going to return an anchor ID to you. And the second thing is if at some point you want to find the anchors, later, you could be you could now take the step further and be like, okay, I'm not just saving this to ASA, but I am going to have my own custom backend because I want to be able to control some of my own things on my backend. And what's going to happen is once you save your anchor and ASA gives you an anchor ID, you can save that anchor ID in maybe a DB in your custom backend, and then later on, when you want to find the anchors again, you can retrieve the anchor IDs from that DB. And it's like, okay, ASA, I'm going to give you all these anchor IDs, and I want you to help me find my anchors by the specific ID. And what ASA is going to do is that it's going to return those anchors back to you. So if you look at 1, 2, 3, 4, 1, 2 helps you create anchors in ASA and then plug it into like your custom app that you're trying to build, your custom Android app and your custom backend. So numbers 1 and 2 would save your anchor and would save your anchor with ASA, and then you'd get your anchor ID back, and then you'd save the anchor ID in your backend. Numbers 3 and 4, if you want to find your anchors again, you can retrieve the anchor IDs from the DB, and then you can go ahead to tell ASA to find nearby anchors for you, that have anyone that it sees that are around you with this particular ID, and ASA is just going to go ahead and return that. And if you want to do that, the first thing you would want to do is go to your build or Gradle and add these 5 dependencies. You would be needing AR core, you'd be needing scene form. You can only do all these things that I'm talking about on AR core enabled Android devices. You need the Spatial Anchors SDK, and you would need AAD if you're trying to do some kind of Microsoft authentication. So this is my Azure Spatial Anchors Manager. And this helps me, I've defined a few functions here that say, okay, I can I can add a listener for when a session is added, when a session is updated. I can add a listener for when, I can remove this listener. I can add a listener for when I locate an anchor. I can add a listener for when I remove an anchor. I can add a listener for when I've located all the anchors that I am looking for. Now, I'm not just looking for one anchor, but I'm looking for a lot more. I can add a listener to say that, okay, I have removed all the anchors that I have added before and, located. I can add a function to create an anchor, and I can add a function to delete an anchor. And then in my own create, I go ahead to specify some important things, create my AR fragments, use my scene view, and add these click listeners that I will use in my application. Now, let's look at this function, which is to save a cloud anchor. So I'm going to define some kind of anchor visual, and then I would set up my local cloud anchor, and that's the method that exists here. So I can create, the local anchor, and I can set it to a place where I want it to be, and then I can, set when I want it to expire. I can decide that I want it to expire tomorrow, a week from today, or never. That's also an option. So once I have set up this anchor, I can decide to create the once I've set up this local anchor, like I have the anchor already, but it's still like saved on my device, then I can go ahead and try and, create this anchor with ASA. And then that would do the honors of uploading the anchor for me. And then I can get my ASA ID back. And then on if it's successful, as we can see here, then I can get my anchor ID, and I can decide to, render whatever visual that I want to render in the position where the anchor is. And I can here I'm using a key value pair as opposed to a custom backend. But if you're doing this personally by yourself, on the last line, if you see what I'm doing, I am just, adding the anchor ID, and then I'm adding the visual. So it's like it's an anchor visuals dictionary essentially, where I'm going to, if for whatever reason I want to look up the different anchors that are around me and render the objects that are supposed to be rendered on those anchors, I will check my dictionary to look up the particular anchor IDs that ASA returns and their corresponding visuals, and I'll just go ahead to render those visuals. Now, another thing to do is, if you want to find a cloud anchor, you can now, okay, I closed the session before, but then I've started a new session so that I can open the app again and find anchors that I've created before. And then I'm like, okay, I'm going to whatever my locate criteria is. Am I trying to locate um anchors of am I trying to locate anchors that are close to me? Am I trying to locate anchors? Am I trying to locate all the anchors? Am I trying to locate the first anchor that is close to me? What am I trying to do essentially? And then I can set that criteria, and I can set my anchor IDs that get returned to me based on that criteria, from my DB or from my dictionary in this case. And then I can start locating these anchors, right? And what's going to happen is when an anchor is found, an event, gets triggered, and I can implement however I want to respond, to that event. If I want to sing and say, "Yeah, you found an anchor," or if I want to, scream and like point in a particular location where the anchor is and immediately render the object that is there. Whatever it is you want to do at that moment now is up to you and up to the kind of application that you want to build. Let's look at this example. As we could see, she was passing through multiple anchors, and it's like, okay, you can see on the right, you've reached point 8 of 12. And then the next thing, once she passes this yellow circle, is like you've reached point 9 of 12. And that's because there were 12 anchors that were found, and she was supposed to follow the sound of the different things, and it just walk as the sound is getting closer to her. It's like she's getting closer to the next anchor, and she walks and she passes this, and once she passes this, she hears a different sound like a game to know that she has actually passed that place. And this is because of wayfinding, and it's possible to do wayfinding in ASA because anchors sort of like exist in a graph. So let's say I have an anchor 1, right? And then in the same session, in the same room, close to each other, I create an anchor 2. Now, because I have done that, my anchors 1 and 2 are related. If I go ahead, still in that same session, to create an anchor 3, now we would see that all these anchors would be created. And this is a way to be able to find, cloud anchors that are close by if that's something you're interested in. So you can decide, okay, this is my anchor locate criteria, this is my near anchor criteria, and I want to set, my distance in meters. So I want to find anchors that are like, 10 meters close to me, starting from this particular source. Just set the different criteria based on exactly what you want, and then go ahead to start locating for anchors that are close to you. And as you find them, you can trigger all of these random events as you wish. If you want to learn more about Azure Spatial Anchors, there is this GitHub sample that is really, really, really helpful that I would suggest you go check out if this is something that you're interested in. If you want to see more various ways that you can use it, if you want to see various samples as well, you can. If you want to see the entire sample in one application that you can use, you can check it out. You can also download the sample and you can run it and do all of that. If you are also interested in learning more about ASA, you can check out any of these links on the screen. I would have this presentation up and I would share the link to that. You can also take a screenshot right now if you want, and you could get access to these maybe later. But if you want to do that now, you can take a screenshot of this page that you could check out the links later. Thank you so much for listening to me talk about Android and ASA and AR and why I think they're nice and why I love them. And if there are any questions now, I will be taking them.